Hey everyone, how are you? In this video, we are going to solve the Leetcode problem of the day, and the problem is rearranging fruits. Now, the problem category is of hard level, but I would say if you approach this problem one step at a time, this is going to be a very easy problem to solve. This problem has some patterns, and you need to understand those patterns and solve it one by one. And I am going to tell you everything you need to know about this problem, the solution approach, and the intuition behind solving this problem. Let's go and let's start solving the problem. The given input in the problem is an integer array called as basket1 and another integer array called as basket2. So we are given a total of two inputs. Both are integer arrays, basket1 and basket2. The output we need to give is the minimum cost to make both the basket equal. So basically we are given two baskets, right? And these baskets are nothing but cost of different fruits. So in both the arrays we are given cost of different fruits as basket1 and basket2. We need to make basket1 and basket2 equal. That is our job, and we need to find what is the minimum cost to make both the basket equal. If you cannot make both the basket equal, if it is not possible, we need to return -1. Now how to make both the basket equal and what does being equal means, that's what we need to know now, right? Alright, first of all, what is equal? How can we say that both the basket are equal? See, the thing is, if you sort the items in or the cost in basket 1 and cost in basket 2, all the elements at the same index should be equal in both the basket. For example, if the basket 1 is 1 comma 3 comma 2 and the basket 2 is 2 comma 1 comma 3, if you sort both of them, it will be 1 2 3 and 1 2 3 at the same index. The elements are equal, right? So it means that both these baskets are equal. We can also check it in a different way. We can say they should have the same elements even if they are in different orders. We have 1, we have 2 and we have 3, right? Alright, so now we know that how can we find if a basket is equal or not. We should focus on finding how can we make both the basket equal if they are not initially equal. If they are initially equal, the minimum cost is going to be 0. If you cannot make them equal, it will be -1. But if you can make it equal, then the only way is we can swap the items of both the basket. So let us say the first basket is 1 1 3 and the second basket is 2 3 2. Right now they are not equal, right? The basket 1 has a 3, the basket 2 has a 3. Both are fine. But the basket 1 has a 1 and another 1. The basket 2 has a 2 and another 2, right? Basically they are the cost 1 2 3, all these are cost of different fruits. We can swap the items in both the basket. We can say if the initial basket is 1 1 3 and the second basket is 2 3 2, if I swap these two elements, if I put this 2 in the first basket, if I put this 1 in the second basket, they are going to be equal, because now the basket 1 will have 1 2 3, the basket 2 will have 2 3 1. Now they are equal, 1 2 and 3, right? They have the same elements or they have the same costing fruits, so they are equal. So this is how we can just swap the items of both the basket and we can make them equal. The cost of swapping. See, the thing is, if you swap the items, you have a cost, and the cost is the minimum value of both the items you are swapping. In the given array we had 1 1 3, in the second array we had 2 3 2. We swapped 1 and 2, right? If we are swapping 1 and 2, basically the cost of swapping will be the minimum out of it, which is 1. So the cost of swapping is 1, and that is the cost, that is the minimum cost to make both the basket equal. Now let us try to understand about the problem with few examples, and it is very important to understand multiple test cases of this problem, because the swapping process is not that easy as it seems to be. And that is why the problem is of hard category, because manually without code also if we try to do it, the process of swapping is not that easy. In the example, the first basket B1 is having 4 elements, 4 2 2 2. The second basket is having 4 elements, 1 4 1 2. Now we can see that there are few elements which are same in both the basket. 4 is same, right? 2 is also same, so they both have a 4 and 2, right? But the other elements are 2 and 2 in the basket 1 and 1 and 1 in the basket 2. So what we can do is we can just swap these two data. We can say this 1 will be going in the first basket, this 2 will be coming in the second basket. So what we are doing is we are swapping basket 1's index number 1 with basket 2 index number 0, right? At index 1 in basket 1 we have 2, at index 0 at basket 2 we have 1. So we are basically swapping 2 and 1, and the cost of swapping is the minimum of these, right? So the cost is 1. And now what the array will look like is, I can say this 2 is going to move here and this 1 is going to move here, and now both the baskets are equal. The other two elements are now 1 and 2. We have a 1 and 2 in the basket 2 and basket 1 both, right? So they are equal. We just had to do a swapping one time and the cost is 1. So the final output is going to be 1 for this particular input. Now let's see one more case where we are getting the output as -1. That is, the swapping is not possible. In this particular example, this is the basket 1, this is the basket number 2, and if you will notice, so both has a 2, so they are same. Both have 3 as well, and both have 1 as well. The only item which is not same is a 4 in the basket 1 and a 5 in the basket 2. They are not same, right? Now we cannot just swap these values and make both the baskets same, because if we put 5 here and 4 here, still both the baskets are different because other elements are same, right? Other elements are same, and the element which is not same, they are different. They cannot be swapped and can be made equal. So that is why the output is -1. Now the first pattern, the first important thing which you need to notice in this particular problem is you can only do the swapping if the elements which are not equal are present in pairs. That is, if I go back to the example number 1, you will notice that this 2 was here and this 1 was here, right? That was our original data. So if I make it original and if I say that it has a 2, it has a 1, right? Both the basket have 4 and 2, right? But the difference were 2 and 1. We were able to do the swapping in these basket because 1 was in pair and 2 was in pair. When we say in pair, it means it is not one time, it is at least 2 times or 4 times or 6 times. That is even number of times. And how we can say this? See, the thing is, I don't want to give you the solution. You need to understand why this solution work, why this intuition is going to work. You have to catch the intuitions at few points, and that's the first intuition. Your elements should be in pairs, and the reason is, if this would not have been in pair, let us say we would have just one number of 2 here and one number of 1 here, right? And this was not the pair here, right? Now if you try to swap, if you do the swapping, this 2 will come here, this 1 will go here in the first basket, the 2 will come in the second basket. Still they are not same, right? Now the basket 1 has a 1 and basket 2 has a 2, right? But if you have a pair and you do the swapping, basically you have two number of 1s here, two numbers of 2 here. If you do the swapping of one of those elements, then what will happen? They will have a 1 here and 2 in the basket number 2, right? So basically the elements are 1 1 and 2 2, right? They are in pairs. If you do the swapping, the moment you are swapping, this 2 will be in the first array, this 1 will be in the second array, right? Now it is 1 2 and 1 2, both are same. But if there are no pairs, you keep swapping these elements and the arrays will not be same. So you need the elements in pairs, or better I can say you need the elements even number of times. Because if the elements are even number of times, let us say the other elements are 3 3 4 4 and you have 1 1 and 2 2 here, we can make up a pair here, we can make another pair, and we can make another pair. Do the swapping for only one of the elements in the pairs and the array will be same, right? Right now the array is 1 1 1 1 3 3 and the second array is 2 2 2 2 4 4. If I do the swapping, this 2 will come here, right? This will be a 1, then this will be a 2, this will be a 1, then this will be a 4, this will be a 3. Now both arrays are same. We have 2 2 1 1 2 2 1 1 4 4 3 3. So that's the intuition which you need to understand. So what we can understand is, if we try to process elements from both the basket, all the element count should be even. We have a 4 and 4 is 2 number of times if we count both the arrays. We have a 4 here, we have a 4 here. So we have 4 2 number of times. We have 2 1 2 3 4 4 number of times, and we have a 1 2 number of times, right? This is our initial data, the count of each elements we have for both the arrays. The count is 2 4 and 2. All are even. If all are even, we can do the swapping and we can make them equal. We can make the arrays equal. But if any of the elements count is not even, it means we cannot do the swapping, and that is what we can see in the example number 2. You try to notice in the example number 2 and try to count the cost in both the basket. The cost are 2. We have 2 number of times. We have 3 2 number of times. We have 1 2 number of times. But we have a 4 1 number of times, and we have a 5 1 number of times. If we have a 4 just 1 number of times, how can we have this 4 in both the basket? Or let us say you have 4 3 number of times. Still you will not be able to divide this 4 in both the basket equally, because if you put a 4 here and put a 4 here, right? You have used 2 number of 4s. Now you have just 1 number of 4 left. Where do you want to put it? In the basket 1? Then basket 2 will not have a 4. If you put it in the basket 2, then basket 1 will not have a 4. So we can say that first of all we need to find each element's count, all the elements which are there in our both the basket. If any of the count is not even, we can directly return -1, right? Now let us say we are not returning -1. It means swapping is definitely possible, right? Now let's try to understand the process where swapping is possible using this particular example. First of all, we need to find each element's count, right, in both the basket. So this is the basket number 1. This is the basket number 2. The different elements we have in both the arrays are 84, 80, 43, 8, 88, 100, 32, 42, 68, 14. These are all the different elements we have. And if we talk about the count of each elements we have, all the elements are present 2 number of times if we talk about both the basket. For example, 84 is 2 number of times. It is 1 here and 1 is here, right? So we have 2 number of 84s. If we talk about 32, we have 2 number of 32s. So like this, for each of the data we have in these basket, all are present 2 number of times. Now, if they are present 2 number of times, then swapping is possible, right? The reason being, I can put 184 here and 184 here in this second basket. We already have them in different basket, so they are fine. But talking about 32, we have a 32 here and we have another 32 in the second basket. We need to put this 32 in the first basket, right? Now, to put this 32 in the first basket, I will have to do a swapping, right? So maybe what I can do is I can say, okay, I have a 88 here and another 88 in the first basket only. I can take the 88 and put it in the second basket. I can take this 32 and put it in the first basket. Now the second basket will have 188 and 132. the first basket will also have 188 and 132, right? So we just need to evenly distribute the elements so that both the basket have same elements. Now the thing is, guys, you will have to understand this example very deeply because mistakes will definitely happen if you directly try to solve the problem. Let's not try to solve the problem using any kind of code. Let's try to solve it manually. If I ask you, try to solve this particular problem manually, what will be the output? See, one of the straightforward way, which is actually wrong, will be this one. And that is something which we all are going to think when we see the problem or the example for the first time. We can say, let's try to find out what are the different elements we have, or what are the extra elements we have in the first basket and what are the extra elements we have in the second basket. Let's try to do it in the wrong way and we will see what's the wrong approach, what's the wrong thing we are doing, and then we will see what's the right thing to do. So what I can say is, I can say, let me see 84, it is here, another 84 is here, so they are fine. So they are evenly distributed, so they are fine. Now we have a 80 in the first basket, we have the second 80 in the second basket. So we have to do the swapping for 80, right? Because we know that all the elements are 2 number of times. So if those two counts are in the same basket, I will have to swap it. I will have to put this 80 somewhere in the second basket. For this, I will have to do the swapping. Alright, let me just try to find out what are the elements I have to swap. Alright, let's talk about 43. So I can see that the 43 is there in the first basket. The second 43 is also in the first basket. So we need to swap 43. What about 8? So I can see that 8 is there in the first and second basket. So they are even. So 8 is evenly distributed. It is fine. Talking about 88, it is not fine. It's there in the first basket and in the first basket. So it has to be swapped. Talking about 14, it is fine because it is there in both the basket. And talking about 100, it is fine. It is there in both the basket. So now we can say that the other elements like 32 is there in the second basket, 42 is in the second basket, and 68 is in the second basket. So what are the extra elements we have in the first basket? It is 84, 80, and 43. All are 2 number of times. Extra elements in the second basket, it is 32, 42, and 68, and all are 2 number of times. See, the thing is, if all are 2 number of times, then simply if I swap 184 from the first basket with another 32 in the second basket, so what will happen? The first basket will have 184 and 132. The second basket will have 184 and 132. These elements will be swapped evenly. So they will be done. Now what is our strategy to do the swapping? Should I swap 84 with 42? Or should I swap 84 with 68? What should be our strategy? See, the thing is, we know that if we swap 2 elements, we are going to consider the minimum element, right? We need to consider the minimum element. And we need to minimize the cost of swapping as well, right? We need to minimize the cost and our answer should be minimum. So one of the things which I can do is I can say, let's do it in this way. Let me take the maximum from the first array, add the minimum from the second array. And the reason is, if I take the maximum from the first and the minimum from the second and do the swapping, then the cost is going to be 32, right? And this way, I'm going to eliminate a bigger element, right? And this is going to reduce the cost. Similarly, for the remaining elements, I can see that the maximum is 80. The minimum in the second array is 42. I can do the swapping and I can say the cost is going to be 42. And for the last element, we have 43 2 number of times, 68 2 number of times. Let's do the swapping and the cost is going to be 43, right? Now this is very straightforward. And why is this going to work? Let's try to do the alternative. If I don't do it in this way, you will see the cost is going to increase. Right now the cost is 32 plus 42 plus 43. And remember guys, I told you that right now we are doing something wrong. And I will tell you what is wrong, but you might not be able to catch what's the wrong. But if you have caught the wrong part, then that is really great. Now, as of now, the cost is 32 plus 42 plus 43, which is actually equal to 117. Now, if you don't follow this step, that let me not take the maximum and minimum, and let us say you are taking the maximum from both the elements, both the arrays, right? So now the cost will be 68, right? If you try to swap 84 and 68, then the cost will be 68, right? So we will have a cost of 68. Now, when we try to swap other two elements, we have 80 and 43 and 32 and 42. If I swap 80 with, let us say, 42, both are the maximum right now. So the cost will be 42, and 43 and 32, the cost will be 32. So 32 is fine, 42 is fine, but now the cost has increased. It was 43 earlier, it is 68 now, right? So from here we can say that our approach of taking the maximum from one array and the minimum from second array is actually going to work. It seems fine, everything is fine as of now, but there is one very important thing which we are missing. We are not considering those elements which are evenly distributed. We are just considering the extra elements, and that is the right approach. We are actually doing it in the right approach, but there is a one thing which you need to understand, and that is, let us say if I want to swap 84 and 32, right? That is what we want to do. We have two number of 84s, right? So we have 84 and 84 in the first basket, 32 and 32 in the second basket. If I put this value here and put this 84 in the second array, this will be 32, 84 and 32, 84, right? The swapping is done. Both the arrays are same, but the cost is 32. Now, let me tell you a very important trick which you need to understand. Let us say the elements are 84, 84, 32, 32. We are not considering a very important element, and that is 8. And I will tell you why 8. But first of all, let's take this element 8. We have a 8 in the first basket. We have a 8 in the second basket, right? So we can take a 8 here and another 8 here, right? Now just focus on these three elements. As of now, the array is not same. 8 and 8 are fine. 84, 84, 32, 32, they are not fine. What we can do is we can say, let me take this 84 and swap this with 8. As of now, I'm not using any programming. It's all about the logic which you can think about swapping. If I take this 84 and do the swapping with 8, then you will see what happens. We have a 8 here and we have a 84 in the second array. Now what we have is, we have 8, 8, right? We have 32, 32 and we have 84, 84. 84 is in the correct place now. We did the swapping of 8 and 84. The cost will be 8, right? Now what we can do is, we can say, let me take this 8 and put this in the second array, take this 32, put this in the first array. So if I do this, then the array will look something like this, right? And the cost will be 8, 32, the minimum is 8, the total cost is 16. And now both the arrays are same. 32 is in both the arrays, 84 is in both the arrays, and 8 again is back in the same array. And this is the logic which we might be missing. If we are not considering this logic of swapping, the total cost of swapping of 84 and 32 will be 32. But if we are considering this logic, the total cost is now 16, right? Again, we can do the same thing with 80 and 42 as well. We have 8, which is evenly distributed again. Instead of 84 and 32, I can say, let's try to swap 80 and 42. The cost will again be 16, right? Because we are considering the minimum cost. So again, the cost will be 8 and 8. Instead of 84 and 32, we are trying to swap 80 and 42. The cost will again be 8 and 8, which is total 16. So instead of 32, the cost can be 16. Instead of 42, the cost can be 16. And instead of 43, the cost can be 16. The total will actually be 48. This is going to be our final answer and not 117. This is the logic we are missing. Now the last piece of information why we are choosing 8. See, we can choose, instead of 8, we can choose 100 as well. 100 is also evenly distributed. Instead of 8, I can choose 100, right? But if I choose 100 instead of 8, then the minimum cost will be 84 and 32, which will be equal to 84 plus 32, which is nothing but 116, which is much more than the original cost of 32 without this logic. We are choosing 8. That is because 8 is the minimum element in both the array, right? 8 is the minimum element. So the cost will be minimum if we try to use this logic of swapping along with 8. So that is the complete explanation. That is what completely we need to do to solve the problem. If you understand this logic, coding this logic is very easy. Let me show you how. Let me jump to the browser and let me show you how can you solve this particular problem using Python. First of all, I have a result variable which is equal to 0. Then I have a data variable which is a default dictionary in which every value will be the integer. Now what we will do is we will start counting the elements in both the basket. Now to implement it, you can have different logic. What I have done as of now is I have zipped both the basket and then try to process both basket data as B1 and B2. If I'm getting the data from the basket 1, I will say plus equal to 1, data of B1 plus equal to 1. If I get the data from basket 2, I will say data of B2 minus equal to 1. So basically, I'm trying to neutralize those items which are in both the arrays. Now let me create another array which is empty as of now. In this particular array, we can fill those elements which are different. Now just run a loop simply in the data where we have stored the count of our items, not exactly the count, but the count difference. So we can say for key comma value in data.items, if anytime the value mod 2 is not equal to 0, I can directly return a minus 1. Anytime if the count difference in both the basket is not even, then I can say minus 1. But if I do not return minus 1, what I will do is I will check if anytime my value is not equal to 0. If value is not equal to 0, it means that that particular item is not evenly distributed in both the arrays. If it is not evenly distributed in both the arrays, I will add that item in my array. I will tell you why. I can say array.extend. I'm going to extend my array with another element, with another list. This list is going to have multiple keys. Basically, these keys are nothing but the items of our basket, right? So I'm extending my array where elements in the array are keys, and the number of time I will put these keys will be the absolute of value. Basically, the key is my actual item in the basket. The value is its count. So I'm storing my elements in this array and I'm actually dividing the count by 2, and that is because I know that items are present in pairs. And if I just do the swapping for one of the items, for example, if I have 84, 84, 32, 32, if I do the swapping of 184 and 132, the other items will not require the swapping, right? So I'm trying to store the items for which the swapping is required. Then I can sort my array. Sorting is very important because what we will do is we will swap the least valued item with the most valued items, right? So that our cost will be minimum. There can be another way to do the swapping, which is I can use the minimum out of both the minimum arrays. I can use the minimum value which is present in both the arrays. So I am taking the minimum item of both the arrays, minimum of basket 1 and minimum of basket 2. And then I can say what's the minimum out of those values. And then I can say multiply this value with 2. And that is because in the example we saw that the minimum was 8, but when we tried to do the swapping, the cost was 816, right? Because now we have to do the swapping 2 times. So the cost will be just the double. Now let's run a simple 2 pointers loop. We have a left index, we have the right index, which is equal to length of array minus 1. And we run the loop from left to right till left is less than right. And we can say result is actually equal to result plus the minimum of 2 values. Either it is array of left, that is our lower value in the array, that is the actual cost of our item, Or we can say if we try to do the swapping with the second logic, the cost will be min item, the value which we just calculated. So whatever is the minimum cost, we are going to take it, and then we are going to move our pointers. Left will be plus equal to 1, right will be minus equal to 1. We can return the result. This is the complete code. This is the complete logic of this particular problem. Now you can submit this, and this is going to pass all the test cases for this particular problem. And you can see the runtime is very good. The memory used is very good. So we have solved this particular problem in a very efficient manner. So that's it for this video, guys. If this video helps you to understand the problem and the solution, and most importantly, if this video has given you the complete intuition of this problem, then make sure that you are hitting that like button, you are hyping this video, and make sure that you subscribe to the channel as well. And I will see you guys in the next video. I want to see you guys in the next video. Thank you for watching this one.